Alright, so moving on now, let's actually update the code to do our sorting to use the Lambda expression. So I'm going to just come down here, and what I'm going to do is I'm actually just going to comment that out for simplicity. And also just so we've got the other code to compare it against. So to do that, we're going to do collections.sort again, because obviously we still want to call the sort method. We pass employees. This is where it's going to get a bit different. So in brackets, now we're going to put employee, employee1, employee, employee2, single bracket, then add our arrow token. And then on the next line, I'm going to type employee1.getName dot compare to employee2.getName. Then I just close off the parentheses. And that's actually it. So you can see this is a lot more concise. Now the lambda is being passed as the second parameter instead of an anonymous comparator. And we split the lambda over 2 lines, which we can do. And if we run it, we should see we get the same results as we saw in the previous video. And you can see we've still got the same output. And just to clear things up a little bit, I might comment that out at the top and just run it again. And you can see we've got our results, and clearly it's sorting and working very well. All right, so let's look at this lambda expression that we've just added. So the 3 parts that the lambda consists of are firstly the argument list. So in this case, the argument list is these here, the 2 parameters, employee, employee1, employee, employee2. The second part of the lambda is our arrow token again, which is this one here. And the third part, of course, is the body, which is the code on the next line, which is basically that code there that I'm highlighting. So how does this actually work? Well, when the sort method needs to compare 2 objects in the list, instead of calling the compare method of a comparator and passing it in the 2 objects, it will instead evaluate the lambda expression using the 2 objects it wants to compare as the parameters to the lambda. Now, one nice thing about lambdas is that it's easy to see what code will be run. And this is especially true when dealing with shorter methods. When 1 or 2 lines of code are buried within an anonymous class, as we've seen previously, that can actually be hard to see or spot very quickly. But the good news is we can actually even simplify this lambda expression even further. Now, if the compiler can infer the parameter types, then we don't actually need to include the types in our lambda. In our case, the compiler can infer from the first parameter, employees, that the objects to be compared will both be of type employee. And because of that, we can actually leave the types out and just rewrite it like this. So I can come back here and actually delete the type, like so. And just run it to confirm that it's still working. And that's still working as well. Now, if there's only 1 parameter, we don't actually need the parentheses in the argument list. So let's take a look at a common use of lambdas. Now for this, we're going to need a JavaFX application. So let's go ahead and create a new project. So I'm going to go to File, New, Project, as we've done countless times. I'm going to call this one, we'll select JavaFX first. We'll call this one ButtonFX, just to keep it simple. ButtonFX. And what we will do is we'll keep the Lambda Expressions project open because we're going to come back to it. So we'll click on New Window so that both the projects are open. And I'll just make this a bit larger so we can see it better. Alright, so first we want to add a button to the grid pane. So we're going to open up our source and go to sample.fxml. So we're going to go and open create a button or add a button. Button fxid. We'll call it the click me button. And whoops, had 2 double quotes at the start. Fix that up. And the text is going to be equal to, we'll just have click me, and we'll do grid pane dot row index 0, and same for column index 0. Okay. Now we could add an action handler here in the FXML. We've done that before in the JavaFX section of this course. And whoops, I accidentally deleted the closing grid pane, so I'll fix that up. Grid pane. Keep it happy. Okay, so we've seen how we add action handlers here, but let's suppose we want to do it in the controller instead of in the fxml file. So we're going to need the fxid, which is why I've added that, so we can access that and actually assign the action handler in the initialize method back in our controller. So let's go back and do that. So what we're going to do first is we'll add the version of the code that doesn't use a Lambda. And we need firstly a private button, making sure we choose the JavaFX one. And it's the click me button. We need to annotate that, XML. Then we need to create our initialize method, public void initialize. So let's do it the first way, that it doesn't use a Lambda expression to set an action. So we'll do that with click me button dot set on action, and it would be new event handler, and I'll just type ev and press enter. IntelliJ adds the code for us. Then we would put the code we want to put in there, which would be in the handle method, would be what we want to have executed when the button's pressed. Very simple, you click me. And using an anonymous class for the event handler like I did there is very common in UI programming, especially actually in Java's old toolkit, Swing, which didn't actually have anything like fxml. Everything actually had to be done using code. So when we run this application, let's do that. We should see that we get a button on the screen and we're able to click it and see the output on the console. Down the bottom you can see in the run window you click me, so clearly that's working. So we've got our action handler added via code, so that's working nicely. But now we actually know about Lambda expressions. Whenever we see an anonymous class definition that only overrides one method, we can consider using a Lambda. So let's actually change the code to do that now. So what we're going to do first is delete the anonymous class parameter. So I'm going to just delete all that code for now. And the set on action will actually be event. Then we need to add our arrow token, and the message that, or the command that we want executed. In this case, the one line, you click me. And again, because I've created a new class, it's defaulting to the wrong language level. I'm just going to change that by clicking over here, and change that back to 8 again, the language level project for lambdas. Click on OK. Alright, so we run this now. And we obviously got the same result, but this time using a Lambda. And the point here is, just closing down the run window, when we only have one parameter, we don't have to put that one parameter inside parentheses. So that's why we've just typed that there without parentheses this time. We only have to use parentheses when there are no parameters or more than one parameter. When we ran the application, you saw that it worked like it did before. You've probably seen enough now to know that we map a method to a Lambda expression as follows. Number 1, the method parameters become the argument list. Number 2, the arrow token is always there. And number 3, the body of the method becomes the body of the Lambda expression. But what about interfaces with a single method that returns a value? Now we've already used one in the comparator example, but the sort method handled the return value. So let's take a closer look with a different example. So we're going to go back to the Lambda expressions project. We're going to add a new interface to the main file. So let's go ahead and do that. And down the bottom here, I'm just going to add interface upper concat and public string upper and concat string s1 string s2, and that's going to be our interface. So this interface contains a method that uppercases two strings and then concatenates them or joins them or appends the second one to the first one. So now that we've added the interface, let's now add a new static method to the main class that uses an upconcat instance to create a new string. So I'm going to come back up here, just below the last class there, the end of the class, and put public final static string. We'll just call it do string stuff. That's going to be upper concat UC. And it's going to get two strings, string S1, string S2. Then we're just going to return our instance upper concat dot upper and concat and the two parameters, the two strings. So the method accepts an object that implements upper concat and the two strings that we want uppercased and concatenated. It calls the upper concat method in the upper concat interface to do the work. Now inside the main method, what we need to do is create a new method. We're going to pass an anonymous class as the first parameter and the first two employees in the list as the second and third parameters. So let's go and do that just up here, just after the for loop. And it's going to be string. We'll call it silly string because it won't make much sense. It's going to be equal to do string stuff. Then we're going to do new upper concat. Press enter so the code's generated for us. And instead of returning null though, what we're going to do here is it's going to be return s1 dot to uppercase plus s2 dot to uppercase, and that's all the method does. But then down here we're going to put a comma in there. Then we're going to pass, it's going to be employees dot get 0, employees dot get 1 dot get name. Oops, I didn't put the get name on the first one, so I'll go back and do that. Dot get name. And let's just print it out. Print out silly string. So when we run this, we can see we get Jack Hill, John Doe. So hopefully at this point you might be thinking, we're using an anonymous class that overrides the only method in an interface. Let's use a Lambda expression instead. Now we still have to define the interface. We can't get away from doing that when we're using Lambdas, but we can definitely simplify the rest of the code by passing a Lambda instead of an anonymous class. And remembering the three parts to a Lambda: parameters, arrow token, and body. So to start with, let's define the Lambda on a separate line and assign it to a variable of type upper concat. So I'm going to just comment out the code we just added, so we've still got it there to refer to. But let's go ahead and define. So it's going to be upper concat UC equals. So firstly we need our parameters. So it's going to be string S1, string S2, our arrow token, and then what we want executed. So S1 dot to uppercase plus S2 dot to uppercase. Now notice here that we haven't included the return keyword. In fact, if we try to add it, doing something like return, we'll actually get a compiler error. When the Lambda body consists of a single statement that evaluates to a value, the return keyword is assumed and the return value is inferred to be the type of the evaluated value, which in this case is string. So I'm just going to undo those changes. But we can go one step further. The compiler can infer the types of the parameters as I mentioned before, so we don't need to include those either. So we can come back here and delete those to make it more concise. And likewise for the second string as well. So you can see that now is fairly concise. And now that we have our Lambda, we can use it as the first parameter in our call to do string stuff. So we can just type in that code again. So we've got our upper concat line there. Then we can type string silly string is equal to do string stuff. You see now the Lambda expression we've created on line 51. Employees dot get 0 dot get name and employees dot get 1 dot get name. And then we should be able to print out silly string. So if we run that, that also works well. As you can see, we've got our Jack Hill and John Doe output again. Alright, so I'm going to finish the video here now. In the next video, we'll continue on with our journey with Lambda expressions. So see you in the next video.